Okay, today on my KD2 robot, we're going to talk about what's on the inside on this original design, what I'd like to change for future designs, and I have done another program with it where I tried two different walking gaits. I kept the flip over, kept the arm wave, but I've also added a turning action. So put all those into the program just to, see how that would all go. So let's get this guy down here, and maybe I better zoom in some. Let's see, something like that maybe. Let's try that. Okay, now it should start turning. Okay, that's going to repeat the program. So those were the new program tests. Now, hang on, I'm going to move the camera around and we'll open this puppy up. Somewhere right around in there would be good, wouldn't it? Hold all the way back. Okay. So in my version, I hold the top on with some screws. These are the screws that normally come with the 9G servos for mounting the screws. And I actually use the same type screws, the mounting screws that come with those, to hold the legs on to the servos. And normal 9G servos with a normal servo control system are only going to give you a 90-degree rotation. Now you can get a little bit better than 180-degree rotation by changing the parameters of the control. The lid has a special lipped area that locks in the switch, comes in behind the top of the lid, pushes on it, the switch is encased in between the plastic. That's just black paint on white, like that. And what I'm powering this with is it's the same size as a normal AA battery, but let's see if we can turn that to where it says the important stuff. There we go. As you can see, it's a, will it focus? Maybe it won't focus. I'll read it to you, if I can read it. It says rechargeable. It's a 14500. It's a 3.7 volt lithium battery. That's what I'm powering it with. Now, 3.7 volts isn't as much as I want to run the servos on, and it's not enough to run the Pololu on. So I'm using step-up voltage inverters, really small ones, because I had them. I didn't have to buy any. For example, that little teeny thing right there is one. One of these can crank out enough current to run 2 servos. If I put all 4 of them on there, it kind of drops them down, kind of was sagging the line. So they're so small that I went ahead and put one in here to step up to 5 volts for these 2 servos. One on this side to step those 2 up to 5 volts. And to keep a clean power supply to the Pololu chip down here, there's one right there. And what else? When I ordered the Pololu chip, I ordered it with the pins already attached. You can get them both ways, without the pins attached, and they come with it, and you can solder them on if you want, or already attached. And that was a mistake. I should have ordered it without the pins, because that adds height, and I knew I was just going to be soldering the 4 control lines on there, a ground and a V+, and it would have sat a little bit lower profile. Now this space that you see between the top of the servo and the top of this body, this is all space that could be used for bunching up wires, but that same amount of space is also available down below the servo down here because the body is symmetrical. So that means, much like the actual KT2 that you see on YouTube, they run a custom-made circuit board in there to distribute things better. And I'm thinking I could do that too. I haven't tried PCBWay's printed circuit board thing, so if I do redesign the body, I'm going to take these support parts out. I'll leave the battery holder things, but I'll shorten them up a little. They don't need to be so wide. And then I can have a circuit board that fits in here that I can attach the Pololo 2. This is the 6-channel one. Polo Mini Maestro 6 2. And if I design the board right, this gapped area here, which would be bigger because this wall wouldn't be there, I should be able to take the servo plugs and plug them directly down onto my custom-made PC board and either directly wire the voltage regulator onto the PC board or plug it, either way. But that'll neaten that up. If I can design the board right, then I should be able to just run some pins directly through the ground, the V+, and the 4 pulse width modulated pins for the servo controls and just solder them in directly. So then there'd just be one neat board. You'd plug in like 4 servos. You might possibly have to plug in the voltage boosters, or you might hardwire them. I really don't know yet. I haven't thought it through too far yet. But that's just something I'm thinking about. And also, right now, much like the KT2 from the real company, mine I'm holding in place with a little wedge. The servos, when they fit in, as you can see, fit into the sides and push all the way up. And when they're in place, then you can take a wedge, which you push in there. And when the lid's on, the lid pushes on the top of that, so that wedge can't move. The servos are held in place. And what that really means is the normal mounting bracket parts, see that plastic part I'm pointing at right there? And it's also back in here. I could cut those off and not even leave them on the servo, which would make putting the servos in a whole lot easier, because right now to fish them down in there between this front wall and this wall, although this wall would be gone, I guess, if I did the PC board thing. But I could just cut those off because they're not being used to hold the servos in any way, shape, or form. The servos are held in place by matching up to the conformity there and pushing against the inside, and then this brace. So those are the changes that I'm thinking about possibly making to the body to make it a little more compatible, a little bit easier to build possibly. And of course, there's still a whole lot more programming things that can be done. Those are just the ones that I did today, because in my first video I told you I wanted to try a few more things. I do like holding this thing together with screws. The KT2 version, they use basically a silicone rubber band around the whole body to hold their top on. They just coil the wires around in that space and then clamp the top down. I kind of like having the screws on there better. But that's it. Here, let's reset the legs. There we go. And of course, having flashing lights are not required. It's just something I thought would be a fun thing to have. Not a great walking sequence, but it's one way of doing it. And there's many ways of doing the top. Since I didn't screw it on, the top just came off, and of course the battery fell out. That's no big surprise, right? In fact, if I put the battery back in, it should reset back to home. And there it goes. All right, let's shut her down. So that's all I got for right now.